Hi, this is Miss Pellegrin, and today we're going to be looking at Module 3, Lesson 4, Writing Products as Sums and Sums as Products. So today we're going to be looking at an area model in order to write products as sums and sums of products. We're going to look at the fact that the opposite of a number is the same as multiplying by a -1 to write the opposite of a sum in standard form. And we're going to recognize and see that rewriting an expression in a different form can shed some light on the problem and how the quantities in it are related. Okay, so in example 1, you are going to have 2 minutes to do A, B, C, and D. So you're going to use the distributive property for those first 4, A through D, and you're going to write them over here. Okay, and then we will go over them, and you will do, you'll try and factor out a common factor to write equivalent expressions for the last 4, for E through F. So on the right side, everything's going to look like the bottom. On the left side, everything's going to look like the top. Okay, go ahead, pause the video and try that. Okay, so for A, you should have had 2x plus 10, because 2 times x is 2x and 2 times 5 is 10. On B, you should have had 3x plus 12, because 3 times x is 3x and 3 times 4 is 12. And then for C, you should have had 6x plus 6, because 6 times x is 6x and 6 times 1 is 6. And then finally for D, 7 times x is 7x and 7 times 3. So we have a minus sign. 7 times 3 is 21. Okay, so pause the video and try E, F, and G. Okay, so here we would have seen that 5 was the common factor. And then 5 times x is what gives me 5x. 5 times 6 gives me 30. So here the common factor is 8. So 8 times x plus 8 times 1. And the common factor in 3 and 12 is 3. 3 times x is 3x minus 3 times 4 is what gives me 12. And then on the last one, our common factor there was 5. 5 times 3 gives me 15, and then x, plus 5 times 4 is what gives me 20. Okay, so we see that in E, F, G, and H, that it is in the same way that dividing is the opposite or inverse operation of multiplying, factoring is the opposite of expanding. Okay, so the terms are being divided by a common factor. So 5 and 30 are both being divided by 5 to find that common factor. Okay. So if we had, let me see if I put this, where I put this. Okay, here it is. Sorry. And that's what we just said. So if we're writing the expression 8x plus 4, and you can just put this at the bottom of your page, would it be incorrect to factor out 2 instead of 4? Okay, so 2 is a factor of 8, and it is a factor of 4. So would it be incorrect to factor out the 2 instead of saying that 4? Instead of doing 4 times 2 plus 2, so 4 times 2 is 8x, 4 times, not 2, 1. 4 times 1 gives me 4. Okay, could we do it with the 2 outside. So 2 times what? 2 times 4x gives me 8x, plus 2 times what is 2 times 2. So is this correct? Well, it wouldn't be incorrect, but to factor it completely, we would need to factor out another 2. So if you did this, because what's inside of it, 4 and 2, still have a common factor, you would have to factor out again, and then end up being left with 4 times 2x plus 1. So you have exercise number 1. You're going to rewrite the expressions as products of 2 factors. Okay, so what that means, rewrite the expression as a product of 2 factors, is just what we were doing right here. Okay, this is a product of 2 factors. Okay, so you're putting it in the distributive property form. Okay, so I'll give you 1. So this one would be 9 as your common factor. Oh, no, sorry, 8 is your common factor here. 8 times 9 gives me 72t, and then plus 8 times 1 is 8. Okay, so go ahead and pause the video and try B, C, D, and E on your own. Okay, so on B, your common factor there is 11. 11 times 5 is what gives me a 55a, plus 11 times 1 is what gives me 11. Okay, on C, our common factor here was 36. So 36 times Z gives me 36Z, and 36 times 2 gives me 72. Okay, on D, our common factors here is 3. So 3 times 48 is what gave 48Q would have given me 144, minus 5 times 3 is 15. And then finally, E. Okay, so our common factor here is 3. 3 times R plus S. Okay, in example 2, let the variables x and y stand for positive integers, and let 2x, 2y, and 8 represent the area of the 3 regions in the array. Determine the length and width of each rectangle if the width is the same for each rectangle. So if this part right here is the same, that it applies to all of these things. So what do they all have in common? Well, they all have a factor of 2. Okay, so we're looking at an array. So just like in a rectangle, you do length times width. So 2 times what gives me 2x? Well, 2 times x gives me 2x. 2 times what will give me 12y. 2 times 6 gives me 12, and then I need the y. 2 times what gives me 8? 4. Okay. Write the expression as a sum. Hold on, does it have it here? Nope. Okay. We want to write the expression as a sum and then as a product of 2 factors. So as a sum, meaning adding everything together, 2x plus 12y plus 8. So this is as a sum. You will need this wording for your homework. Okay, and then as a product of 2 factors, 2 times x plus, so this is on the outside, the parentheses, 2 times x plus 6y plus 4, that is as a product of 2 factors. Okay, so that will be helpful when you are going to do your homework. Okay, and example number 3. You are going to pause the video and try it on your own, and go ahead and you may discuss with your group. Okay, so you were asked to write 2 different expressions that represent the total amount of the group that they spent, and then explain how each describes the situation in a different way. So we are looking at it. It includes, for their miniature golf and arcade, it includes 2 rounds of golf. So 2 rounds golf. 20, that should be golf. 20 tokens. Plus, we're getting $3 off. I shouldn't have both the negatives on it. So, $3 off. There's a group of 6 friends that purchase this package. Okay, so we have 6 friends that get 2 rounds of golf, plus they get 20 tokens, and then they have $3 off, so it's being taken off, so I'm taking off 3. Okay, so this would represent the friends. This would represent golf, 2 rounds. This would represent the number of tokens, 20 tokens. And this would represent the amount off. Right? But I could look at it another way. I could say, okay, so in total, they're going to have 12 rounds of golf. Total by everybody. Plus, in total, they're going to have 120. Between all 6 of them, they're going to have 120 tokens. So that's the total of the group. And then they're having a total of $18 off. Okay. So one may be easier than the other to plug in the information. Maybe we want to look at this one because everybody is paid all together. Maybe we want to use this one because we want to just use what's on the inside to see how much each person is paying, because this is what just one person would be getting, and then we take that and we multiply it by 6 to see what the total would be. Just depending on the information that we're asked, depends on the kind of equation that is best for us to write. Okay, and you should have used G and you should have used T because it did say that in the problem. Okay, so In exercise 4, we are talking about the opposite of a number. And so the opposite of 2 is -2. We had done that before. So -1 times 2 is equal to 2. So -2. So then -1 times n would be equal to a -n. Okay, so two mathematical expressions that represent the opposite, so of 2a plus 3b. So the opposite of 2a plus 3b. We could say -1 times 2a plus 3b. That would be the opposite because we would have -1 is the opposite of these things together. Okay, or we could have a -2a plus 3b. Okay, so this is the same as having a 1 on the outside. You're distributing that negative sign to both things. Okay. So use the distributive property. So we had -1 times 2a plus 3b. Use the distributive property to write an equivalent expression. So -1 times 2a is -2a. -1 times 3b is a -3b. Okay, and if you need the plus sign, -2a plus, and then a negative times a positive is a -3b. But if you notice, we don't have those two signs. Subtracting, which is what we have here, is the same as adding the inverse. So these two are the same thing. Okay. So either of those would technically be correct. This is what you're going to see. This is kind of what we've been working with. Okay, so to go from -2a minus 3b, what we had down there, to -2a plus 3b, what process occurs? What happened? Okay, so we had a takeaway, and here we're taking away both of these. So we were taking away here, we were taking away here. So this way we just put these together and said we're taking them both away. So we are factoring out a -1. Okay. So what is the opposite of -6v plus 1? Negative v plus 1 would be the opposite. We just put the negative sign on the outside like we were talking about in this part that you didn't really have in your notes, but you should have been writing somewhere on a loose leaf sheet of paper or blank area. Okay, so using the distributive property, write an equivalent expression for part A. So -6v plus 1, use that distributive property. A negative times a negative is a positive. A negative times a positive is a negative. 6v is a negative. So that would be our equivalent. It would be the opposite. The opposite of negative 6v is positive 6v. The opposite of plus 1 is minus 1. Take away 1. Okay, so rewrite 5a minus a minus 3b in standard form. Justify each step applying the rules for subtraction and the distributive property. So we're going to start off with writing it out. 5a minus a minus 3b. Okay, so we know every time we see subtraction, we are going to add the inverse. So subtraction means we're going to add the inverse. Okay, so we have 5a plus a negative a plus a negative 3b. So both of those subtraction signs we changed to addition signs and did the opposite of them. Okay? Okay. So let's see, how do they have this? Parentheses here. This together. Okay. So what we just talked about, the opposite of a number is the same as multiplying by negative 1. Okay, so 5a plus a negative 1. So we're showing that we're multiplying by a negative 1 instead of just that negative sign. That we're multiplying that times a plus a negative 3b. Okay, so then we're going to do that distributive property. So we have a negative 1 on the outside of the parentheses that we're multiplying here. So we're going to show that 5a plus negative 1 times a. Then we're doing here, so then plus, and then we're doing negative 1 times a negative 3b. So that's us showing that distributive property. Okay, so then we have 5a plus negative 1 times a is negative a, plus negative 1 times a negative 3 is a positive 3. We don't need to write plus plus, 3b. So that's this little part. I'm not going to write all of that over again right here. And then we're going to combine together. So we have 5a plus a negative a is 4a. So I'm taking one of those a's away, and then plus 3b. So expand each expression and collect the like terms. So go ahead, pause the video, and try A on your own. Okay, so you should have seen that there was subtraction first, so negative 3 times 2p plus a negative 3q was the first thing that we should have done. Then after that, we have the negative 3 on the outside, so we're doing the distributive property. So we're doing negative 3 times 2p plus negative 3 times negative 3 times negative 3q. So negative 3 times positive 2 is negative 6p plus 2 negative signs. That's an even number of negative signs, so that's positive. So 3 times 3 is 9q. Okay, I don't have any double signs. P and Q are not the same letter, so this is my final answer. Okay, so go ahead and pause the video and try B. Okay, so in B, negative A, we see subtraction, so we're changing that to addition. We're adding the opposite of A and not minus B. We have to change subtraction to addition, so plus a negative B. Okay. So then our next step is that the opposite of this, opposite of the number, is the same thing as multiplying by a negative 1. So negative A plus, so you're really multiplying. This is the opposite of this. So you're doing negative 1 times A and plus negative 1 times negative B. So negative A plus, we have multiplication, which would give me negative A plus negative times a negative is positive, so even number gives me a positive, even number of negative signs. And then negative A plus a negative A is a negative 2A plus B. And that is